pathfinding improvements, and some other things. Today, we're gonna finalize the pathfinding and add a few debug options so we can easily debug it in the future and also visualize it. And we're also going to take a little bit of time just to fix a few things here and there in the projects that are a little bit annoying right now. So let's get to it. Okay, so in Unreal, I'm gonna show you the first thing we're gonna fix, and it is in the tab Pathfinding, and it is when we are clicking on one of those buttons, either the Select Tile or the Select and Find Path buttons. You can see that the other button is also highlighted because both actions are using the same action for the left click, so we're just gonna go fix that real quick. So let's just stop for now and go fix it. So this is in the debug menu, in the actions, and inside the button underscore action. So let's open that one and go straight into the graph. Here, this is where we are setting the color blue on our button, so we can see that it is only using the left click action, so we're just gonna include the right click also, so I'm just going to duplicate all that and change the left click for the right click, just like that. And then we're just adding an AND right here just to make sure that both conditions are true before setting the blue color on the button. Oh, and I almost forgot, we have to replace the left click right here by the right click, otherwise it's going to compare with the left click, and that's not what we want, so we have to replace right here for the right click action. And that's it for the color, but now we just have one other place right here when we are clicking on the button to choose which action to select, and it is just using the left click action for now, so I'm just going to deselect all that, and I'm going to copy paste all those nodes instead, and then connect them to the branch like so. And I guess that's it, so I'm just gonna compile and close this blueprint for now. And now if I press play, I'm gonna go in my pathfinding, I can click on my select tile, which is the action to select a tile, and then the select find path, which is the action to select and find path, and you can see that only one of them is highlighted and selected. Perfect, that's exactly what we want. Good, we can now stop again. The next thing I want to fix before going into the pathfinding is inside the actions, and in the pathfinding actions, we're just gonna open action find path to target, just like that. And then I'm going to go back in the level entry, and you can take a look at the log here. If I close the action now, it's going to print a few warnings in the log, and it is because we are trying to call some code in some invalid variables. So we're just gonna fix that, and this error is also happening for the show tile neighbors. So I'm gonna do the same thing. I'm gonna close the show tile neighbors. We can see that we have a few warnings, and it is the same for the select tile action. So same thing right here. If I clear the log, I can see, oh, okay, this one, it didn't show, but I'm pretty sure it does. So I'm just going to open the select tile, and I'm also going to open find path to target and show tile neighbors. So let's open these three blueprints, and we're just going to fix it real quick. And the fix is pretty simple. We're just gonna go back in the event graph right here. We are using the event destroyed to execute the action again, but instead of using the event destroyed, we're just gonna use the event end play instead. This event is also called when the blueprint is destroyed, but it is not called when the blueprint is destroyed in the editor, like when we are closing a blueprint. So I'm just gonna use the end play instead. That way this event is only going to be fired in game, and that's exactly what we want. So use the end play right here. And I'm also going to do the same thing in the other one. So I'm gonna go in the event graph, paste the event end play, replace the destroyed, and go in the select tile, event graph, paste the event end play right here to replace the destroyed. Now we can compile all three blueprints, and it should now not print any warning when we close them. So I'm just gonna clear the log, close all three blueprints, and see we don't have any warnings. Perfect. Okay, so the next thing we want to fix is a little bit related to the pathfinding, so I'm just going to press play, go in my pathfinding, and select my action and include the diagonals. And what I want to fix is this behavior right here. So instead of going straight to the target, the pathfinding is going all the way down and go back up to the target. In the end, it's the same cost, it's the same distance from this tile to that tile in a straight line or in diagonal for the pathfinding, because it's the same amount of tiles, but it's not pretty, it's super ugly. So we want to prevent the pathfinding from doing that. And it is also doing the same thing right here, I think, yeah. It's going a little bit wiggle before reaching the target, the same amount of tile as going straight to it, but it prefers going all the way down and wiggly a little bit. So we just want to fix that because it's not pretty, and it is easy to fix. So let's go do that first. I'm gonna stop and go in my pathfinding blueprint. So in the grid BP pathfinding, let's open that one. And here I'm going to need a new function just to check if a tile is diagonal to another one. So I'm just going to create a new function, name it is diagonal. The function takes two inputs, so two endpoints for index 1 and index 2, and then returns us a boolean telling us if they are in diagonal or not. And that's how we're going to do it. So it's not the most performant, efficient way to do it, but since it's the fastest way to do it right now, I'm just going to do it right now like that. And then if we need to optimize it in the future, well, we're going to do it in the future. So let's see how it goes. Here I'm getting all the neighbors of the first index without the diagonals, and then I'm checking if inside those neighbors we are containing the second index. So if the second index is inside the first neighbors, which are not including the diagonals, it means that the index, well, it's not in diagonal because it's part of the list which doesn't include the diagonal. So that's how we're checking if it is a diagonal, and then we just have to inverse the condition and return it at the end for it to work. And I'm actually going to make the function pure. Okay, now let's go use this function, and we're gonna use it in insert tile in discovered array. Right here, when we are setting the sorting cost, we want to affect the sorting cost just a little bit when we are in diagonal. That way we are gonna make the pathfinding believe that this tile is a little bit more expensive, not too much because we don't want to affect the pathfinding, we don't want to break it, but we just want the pathfinding to prefer using a tile that is not in diagonal opposed to a tile that is in diagonal. So since we are going to add that right here, right before setting the sorting cost, I think it will be cleaner to just convert that inside a function. So let's right click and collapse to function right here. Function that I named getTileSortingCost, and I also made it pure just because it looks better, I think. And then for the input variable, I named it tiledata, and I renamed the output for cost. And then we can open the function just to add the logic in there. And the first step is to check if the indexes are in diagonal, and the way we're going to do that is just checking the index, compare it with the previous index, and check if both of them are in diagonal or not. And next we want to add the result of the boolean to the result we had before, so let's go do that. But first we have to multiply the previous result by 2, just because we don't want the is diagonal to be too important in the pathfinding. We still want to have this as the main priority, and then just add the is diagonal at the end just to offset the result a little bit. So let's multiply all that by 2 just so it's more important, and then we can add the result of the boolean right here. And we can do that by just dragging and dropping on it. Unreal is going to convert it for us. So if the boolean is false, so if it is not a diagonal, it's going to add a 0 right here, and if it is a diagonal, it's going to add 1, so it's going to be a little bit more expensive in the case that it is a diagonal. And that's it, that should fix the problem. So we are multiplying by 2, and then we are adding the diagonal before returning the cost, and that should fix the problem. So let's compile and go test and see how it looks. So now if I press play, I'm gonna go in pathfinding, find path, include diagonals, and now, okay, I can see that the path prefer using a straight line instead of a diagonal, so that's good. That's exactly what we wanted. So that's great. Yeah, it looks way better than the wiggly path that we had just before. Perfect, so this one is fixed also. Good, we can now stop. And actually I'm just going to jump right back in because I want to show you the next thing we're going to do, and it is the debug text, because right now we just have the tiles indexes on them, and that's pretty nice, but it would be nice to also display maybe the cost to the target, the cost from the start, the cost to enter the tile, and things like that, because right now the pathfinding works, and I know that it works because I worked with it for over 200 hours or maybe way more than that, but you don't know that it works, you just believe me right now. So let's just add some debug info just to make sure that you also know that it works and the way it works and everything. So let's just start by adding some debug text on the tiles, and then we're gonna add some more colors and stuff, but let's start with the text. So let's stop and go do that. And this is happening in the debug menu in BP debug text on tiles. So let's open that one. And right here we have a ton of stuff to change. There's a lot that's going to change because right now everything is based on one boolean, and we're gonna add a bunch of them. And also the way we are displaying the text is pretty static. We can't really happen to it easily. So we're gonna change a few things here and there, and we have a lot of work to do. So let's get to it. And the first thing is, how many variables do we need? Because we want to display a bunch of different texts, and we don't always want to display all of them at once. So let's create a bunch of them. So 1, 2, 3, 4 I think we need. So let's create 4 booleans. And the 4 booleans are show cost to enter tile, show min cost to target, show cost from start, and show sort order. That way we're going to be able to display all of them at once, or one of them, each of them, whatever. We can decide which one we want to display. So here are the 4 booleans. The next step is to include all those 4 inside the setShowTileIndexes function right here. We're going to rename the function so it makes more sense, but yeah, we're going to include all those 4 boolean. We're going to all set them right here. And this is how I connected it. It's debug code, so we don't have to make it super pretty also, so we're just going to connect it like that. So yeah, I renamed the function setShowTileText instead of setShowTileIndexes, I think, and then I connected all 4 booleans to the beginning of the function like that. And for all those nodes right here, I'm just going to also collapse them inside a function. So right-click, collapse to function. I named the function UpdateTextOnTiles and I connected it just right here. After setting all the booleans, we are calling this function, and then we can open it because we're gonna change a few things in there. And actually we don't have that much to change, we just have to make sure that the condition right here includes all 5 booleans. So we are connecting all of them to an OR, so if any of them is true, we are going to display text on the tiles, otherwise we're just going to clear them all. So include all the booleans inside the OR and connect it to a branch. And actually, since we are going to use that a few times in the blueprint, I'm just going to collapse it inside a function also. So right click, collapse to function, which I can make pure already, otherwise it doesn't work pretty well. And I'm just going to rename it. And I renamed it want to display any text because that's exactly what we want to know. Do we want to display text? Yes, no. If yes, we are displaying text. If no, we are clearing everything. Perfect. And it's now time to do the more complex function. So let's open UpdateTextOnTile and we're gonna change a bunch of stuff here. Starting with the condition at the beginning, because right now it's using one boolean, but we want to include all of them. So we're gonna call our new function want to display any text like that. And here we have a few things to change, so just follow me. I'm just going to start by deleting the comments because they are in the way. Right here I have my text, my set text. I'm just going to copy and paste it right here. Actually cut it and paste it so it's out of the way. And then we can connect all that together like that. So we are going to first set the text inside the variable, so we are deciding which text we want to display, and then we are going to display it on the tile and move the tile to the right location. So we're gonna do that in 2 steps, so I'm just going to include a sequence right here, so sequence, and the first step is going to be the text, and the second step is going to be everything else. So I'm just going to connect that into the second pin, and then we have a bit more logics to do for the set text right here, but that's how it's going to look. So first we are setting the text in the variable, and then we are applying the variable to the text component. Then the next thing I'm going to do is convert my text variable right here. I'm going to convert it from a string to an array of string like that. That way it's going to be simpler to add different text in there and remove text and stuff like that. And then we are going to be able to just combine all those strings together at the end. But right now, if we compile, we can see that we have a problem. So let's fix this one. And we're gonna fix that with a join string array, just like that, which we can connect the array as input, and then it returns us only one string containing all the elements in the array. For the separator, you can use anything you want. You can use a space, you can use an enter, a dash, or anything. But in this case, I'm just going to use an end of line, which is doable by holding shift on your keyboard and pressing enter. So shift enter is going to create a new line. So each element in the array is going to be written on a new line. So we're gonna have a multi-line text here that is going to be written on the text render component. And now if we compile, everything should work perfect. And one last thing before we go add some text in the variable, we're just gonna do a little something right here at the beginning. And here it is, we're gonna make sure that the text is not empty before spawning the actor, setting the text, moving the actor in the world. We're gonna make sure that we have something to write on it because we don't want to spawn an actor for no reason. So if the text is greater than 0, it means that it is not empty. So if it is not empty, we're gonna spawn an actor and write on it. Otherwise, we're gonna destroy the actor if it exists. If it doesn't exist, it doesn't do anything. But if it does exist, we're gonna destroy it just to optimize a little bit. So greater than 0, spawn the text. Not greater than 0, destroy the text. Okay, it's now time to go do the text variable. So I'm gonna go all the way up here after this sequence, and I'm actually going to add another sequence right here. And the first pin of the sequence is for the show tile index. So we're checking if we want to display the tile index, and if it is the case, well, we can just keep the same append that we had before, but instead of doing a set on the text variable, we are doing an add because right now it is an array. So we're setting the text for the index right here, and then we are adding it into the array as first element. And the second pin of the sequence is for all the other variables. So everything that is related to the pathfinding, we are going to make sure that at least one of them is true before executing this pin right here, because we're going to need to fetch inside the pathfinding to access the data, and we don't want to do that in the case that we don't have anything to display, because it's going to be a little bit expensive if we do that for every tile for no reason. So we're going to make sure that at least one of them is true before executing that. And that's all we are getting the pathfinding data. So we are getting from the pathfinding data in the grid pathfinding the index of the tile, which is the same index as we have right here. And if we find it in the data, well, it means that we have the pathfinding data for that tile, so we can set it inside a variable and then use it to set all the other text right here. And here I added a new sequence, 1 pin for each of the variables, so 4 pin for the 4 booleans, and I'm starting with the first one, which is the show cost to enter the tile. I'm doing a branch to check if we want to display it, and if we do, well, I'm feeding in the pathfinding data, I'm getting the cost to enter the tile, and I'm appending a prefix, which is enter colon, just to have a prefix so we know what number it is, and then we can add that to the text variable. And then I'm doing the same thing for the minimum cost to target. So if we want to display the minimum cost, we're fetching it from the structure, we are adding a prefix, which is min colon in this case, and then we are adding it inside the array. But there's one difference right here. I'm checking to make sure that the variable is initialized, or in other words, if it is not using the default value that we set in the structure. So the default value in the structure is 99999. So if it is still that value in the pathfinding data, I don't want to display that number because it doesn't make sense anyway. So I prefer having nothing written than having that weird number in there. So I'm just checking that it is initialized by checking if it is not equal to the default number. And if it is true, well, I'm displaying it. Otherwise, I'm just ignoring that one. And then I can do the same exact thing for the cost from start. So we are checking if we want to display it. If we do, we are fetching it from the structure, and then we are adding a prefix and adding it inside the array. The prefix is start in this time. And the last one, it's a little bit different, but it's pretty much the same thing. We check if we want to display the sort order. If we do, well, we want to find the sort order from the discovered tile indexes. So we are getting the index, we are doing a find on the discovered tile indexes list. If it's not equal to -1, it means that it is inside the list, otherwise it's not. So same thing as the other one, if the value is not valid, we don't want to display it for no reason. And then appending a prefix, which is sort in that case, and adding it to the text. And while we're here, I think it will also be a good idea to display the cost of the tile, not only the index, because right here we have the sorting index, but here we have the sorting cost, so both values are useful. So we can do from the find that we did for the index, we can fetch inside the second array, which is the sorting cost, and feed it inside the append. Right now I'm just placing it inside the brackets before sending it into my add text right here. And here we go, we're done with the text formatting, and that's how it looks when I zoom out a little bit. There's a lot of nodes right here, but whatever, it does what it does. Anyway, now we can call this function, and it should display the text on the tiles, I hope. So let's go in the event graph to connect to the function the same way we did for the grid right here. And right here, we're going to use the same technique that we did for the grid. So we are going to use callbacks because we don't want the pathfinding to know or be aware of the debug menu. We just want the debug menu to hook itself inside the pathfinding and fetch the data it needs from there. So we're going to need some callbacks, and we don't have the callbacks. We can get the grid pathfinding right here, but we don't have any callbacks in there. So we're going to go create two callbacks, the same thing we did for the grid. So we're going to need one for the tile when it is updated and one when the pathfinding data is cleared completely. So we're going to go create those two callbacks in the grid pathfinding. So let's open that one. And I'm going to create two new event dispatcher right here, bottom left corner. So the first one is named onPathfinding data updated, and I have an input here in the top right corner. It is an index, so an int point right here. And for the second one, it is onPathfinding data cleared, and I don't have any inputs for it. And now we have to go attach them somewhere, and the easiest one is the cleared. So we're going to go in the clear generated data function. We're going to go all the way at the end, and then we can call it right here. So call the onPathfinding data cleared at the end of the clear function right here. And for the second one, on the pathfinding data updated, we have to call it inside the discover tile function. So let's go there. We can place it at the end of the function right here. So call it after we are adding the pathfinding data inside the structure, inside the mapping, like that. And then for the index, we can just take the same index right here. Okay, good. We can now compile and go back in the other blueprint. And then right here at the end of the begin play, we can hook ourselves to the new callback. So we have the first callback, which is onPathfinding data updated, which we are using to call UpdateTextOnTile function, this one right here. And then for the onPathfinding data cleared, we are calling the function UpdateTextOnAllTiles to update all the tiles. And I think that's it. I think we can now test it, but first we need a few checkboxes in the debug tab. So let's just go open that one. So it's going to be in the debug menu, in the tabs, open the tab pathfinding right here. And I'm going to duplicate this checkbox a few times. And here you go, here are my checkboxes. So I just changed the text and their names. So I have indexes on tile as before, cost to enter the tile, min cost to target, cost from start, and sort order right here. And now I will implement all the events. So you can select the checkbox, go all the way down, implement the event, and do the same thing for all the other ones. So select the next one, go down, implement, next one, down, implement, and the last one, down, implement. Events that are all connected together like that. So whatever checkbox is checked, we are going to call the same function, which is the set show tile text right here, and passing it all the check state of all the checkboxes. So whatever checkbox is updated, we are still going to update everything based on all the new checkboxes state. And then last thing, in the begin play right here at the end of the begin play, I just make sure that all the check state, the initial check state of all my checkbox are the same as the ones that are in the blueprint. So I'm getting all the blueprint variables, so all the bools right here, and I'm setting the check state of all my checkboxes based on them. Okay, let's go test all that. I'm just going to compile everything, go play right here. I'm gonna go in my pathfinding, I'm gonna zoom on my grid a little bit, and now I'm just going to draw a path. Whatever the path it is, doesn't matter, I have a path. Now if I show my text indexes, so that still works, then if I add the cost to enter the tile, we can see that it appears on the tiles that have a cost that we discovered during the pathfinding, then the minimum cost to target, which is that one, then the cost from start, and then the sort order. Okay, we have a ton of text. Okay, it's nice, it seemed to work, but it's a bit too big for the tile, so I think we're gonna have to adjust the scale a little bit depending on the quantity of text we are displaying, and that's actually the next thing what we're gonna do, so that's so much fun. Okay, I'm gonna stop and go do that. It is in the debugTextOnTile function. Then I'm gonna go in my UpdateTextOnTile function right here at the end when we are setting the actor transform. And to do that, we're gonna need a new variable to keep track of the length of all of our strings. So I'm gonna start by duplicating the text variable. I'm gonna change it for an integer instead of a string, and I'm going to rename it text_length. And now what we have to do is go everywhere we are adding elements in the text array and also add them in the text length. So I'm just gonna go right here. We have 3 of them, here, here, and here. And I added them like that, so we are doing a len on the string to access the length of the string, and then we can add them inside the other array. Then we have 2 more places to add it, so I'm gonna go right here a little bit above to add it from here, and we also have right there where we are setting the indexes, so just do an add on that one too. And now we can go back down where we are setting the transform right here. And I'm gonna connect it like that. So we are getting the max of int array of our list, which we just created. So this is going to return us the longest string in our array, the one with the most characters. And then we can use that quantity of characters to determine how wide is the text. So I'm gonna multiply it by 30 right here because I'm giving 30 units per character. You can use the value that you want right here. It depends how big you want your text. And then you can divide the tile size y, because this is the width of the tile, by the quantity of text multiplied by the size of each character, and then we can pass that inside the transform scale. So now the longest string in our list is going to affect the size of the component. Okay, let's go see how it looks. I'm gonna press play right here, pathfinding, show all my text, and then I can draw a path. Here you go. You can see that text is smaller if I have more text on them, and if I reduce the text, we can see that it gets bigger depending on the length of the longest element in my array, like that. So when I don't have any text on them, the text is bigger, otherwise it's smaller, which is good. It's pretty small right now, but we can zoom if we want to see it, but this is because of the triangle grid. It is a little bit thinner than the other grid types, donc I just made it that it works for all the grid shapes, but otherwise you can make it bigger if you're not trying to support the triangle grid. It doesn't really matter anyway. But yeah, so I guess that works. Now the text is not overlapping each other. Perfect, we can now stop. So here I have a simple grid just to make sure that all the text numbers are working properly. So first we have the index, which we know that works already, so we can ignore that one. And for the cost to enter the tile, well, it's all one for now because we don't have any ground types, different ground types that will have a different cost. So right now everything is one, so let's assume that it works. Next, we have the min cost to target. So I know that that one works well on the grid shape. It doesn't work well on the other ones, but we're going to come back to it later. For now, let's focus just on the square. So 5, the distance from this tile to the target, which makes sense. So 5, 1, 2, 3, 4, 5. That's good. This one's 3, so 1, 2, 3. So all these numbers make sense. This one is 2, so 1, 2. That makes all sense. And then we have the diagonals, which will affect those tiles also. So right now it's 4, 4, 4 instead of 5 and 5, 3, 3, 2, 2, 2, 1, 1, 1, which makes sense because let's say we have here, it's 3, 1, 2, 3. So it takes 3 steps to reach the target. So these values work pretty well for the grid square, but it doesn't for the other ones, as I said, but we're going to come back to it a little bit later. We can go to the next one for now. Next one, that is the cost from start. So let's check that one. Okay, we have 1, 1, 1, 1, 1, which makes sense because we are still including the diagonal. So this is just cost 1, that's good. Then 2, 2, 2 for these ones, 3, 2, 3, 4, that's perfect because, yeah, right here we have 3, 1, 2, 3. Okay, that works perfectly. And now if I uncheck the diagonals and I generate a new path, 1, 1, 1, that's good. 2, 2 makes sense because 1, 2, 1, 2, 3, 4. Okay, this is all good and I know that it works for all the grid shapes. So for now, we can skip that one too. Perfect. So let's uncheck it. And the last one is the sort order. So let's check that one and see if it looks right. I think it does, because right now this one is the index 0 in the sort order, which is right because it's the last tile. That's good. And then all the other ones are 1, 2, 3, 4, 5, 6, 7. I guess it makes sense. Right now, all of them cost the same exact amount. So the Pathfinding doesn't know which one to use. It just uses the first one it found, which makes sense. So it looks like everything works, but what if we regenerate the path after the text was spawned? Okay, I don't know if you see the difference, but I see it. Here on the right, I have the index 0, and it's also the index 0 on the left on the start tile, which is not in the discovered list anymore. So that's a little bit weird. In the top left corner, I have another 0. We have 2, 2, 2, 4, and 2 6s, which doesn't make sense because that's not how an array works. We can only have one index per number. So yeah, that's a bit broken, but what if I pass my mouse over everything? Okay, everything's updates. So now the sorting index is back to 0 for the last one, and then 1, 2, 3, 4, 5, 6, 7. So these are the right numbers, but when I regenerate the path, it doesn't work. And this is because the indexes are not updated once we are adding a new element inside the array. Because when we are adding an element in the array, it offsets everything else that is afterwards, but it doesn't call the text, the debug text, to tell them that hey, those tiles have been updated, so update the text. It doesn't call them, so we have to refresh them either manually by passing the mouse over them, or maybe checking and unchecking the checkbox just to update all the values. But that's a little bit annoying, so I'm gonna start by fixing that one, and then it's gonna be a little bit better. And that's how we're gonna fix it. It's a cheap fix, it's not like a really good fix, but it's a simple and fast way of doing it. So I'm creating a new event, which I named event underscore reupdate all text after delay. And I'm passing into a retriggerable delay, which means that as long as this event is fired, it won't be completed because it's going to reset, 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 reset. So that's fine because we don't want this event to fire a bunch of time, only once after we are done updating the whole grid, and then we are re-updating everything else again. So in short, the idea is every time we are updating something in the pathfinding, instead of calling the UpdateTextOnTile function to update that one specific tile, we're just going to call this event right here. And then once the pathfinding is done and everything is completed and calculated, once we have all the data that we need, we're just going to call UpdateTextOnAllTile only once for everything. But anyway, if we want to connect this event to that callback, we have to have matching signatures. So both events have to be built the same way, which means that they need to have the same amount of parameters input. And in this case, it needs to have one input, which is the index. So it needs an int point. And in this case, I named it index just because, but we're not going to use it. It's just so we are able to connect it to the callback. And now that this event has the variable, we can select it directly in the drop-down menu right here. So event reupdate text after delay. Here we go. So now everything should work as expected. And here we can see that it works. So every time I'm regenerating the path, so every time I click, it generates the path, and then once it's done generating the path, it waits for the small delay and then updates all the text only once at the end. So yeah, now all the text should be good and match the right data and everything. So perfect, it seems to work. And just to make sure, here I'm just showing the sort order, which is the right one. So it starts by 1, 2, 3, 4, 5, 6, 7, and the 0 for the last tile, and the start tile doesn't have a sort order anymore. So it works perfectly. Perfect. Okay, it's finally time to fix the minimum cost to target for the grid shapes, triangles, and the hexagon. Actually, I could just simply give you the formulas, but I think it will be more interesting if we are able to visualize what's happening and what the formula is doing. So to do that, we're going to create a new action. And this time we're going to do it a little bit differently. So in the action grid right here, we're going to create an action, a child of a select tile. That way our action is going to select a tile and then do something else, which in this case calculate all the minimum distances for all the tiles in the grid. So to create the child class, we can just right click on action select tile and create a child blueprint class. And then for the name, I renamed it action underscore select tile underscore calculate min cost. And then we can drag this new blueprint inside the Pathfinding folder. Move here. And then we can open it. And here what we want to do is override the execute action event. So I'm going to go in my function, click on override and choose execute action right here. And here, since we want the parent action to keep being executed, because we're going to need it, because we want to select a tile and then do something else, so this is going to select a tile, so it's going to need the index, so we have to reconnect it like so. And then the rest of the function is going to go that way. So first, we are clearing the generated data, because we're going to generate new data, so we want to clear it first. Then the next step is to make sure that the selected tile is valid, otherwise we're not going to execute any code in this event. And here's the main part of the function. I know there's a lot of stuff here, but it's pretty simple and straightforward. So the first thing we do is getting all the tiles in the grid, so we're getting all of them, like everything. And then we're looping through all of them also. And while we are looping through them, we are discovering them. We are discovering all the tiles. Meaning that we are generating pathfinding data for all the tiles and we are adding them inside the pathfinding data, which is then going to be displayed on the top of the tiles. And while we're doing that, well, we are calculating the minimum cost between two tiles, which in this case is the minimum cost between the tile that we are discovering, so this tile right here, and the selected tile, because we select a tile and then we are calculating the minimum cost between all the tiles on the grid compared to that selected tile. And that's it. There's a lot of nodes, but it's not doing much. It's actually just generating a ton of numbers that we'll then be able to look at and see what's happening with the minimum cost between two tiles. And there's just one last thing, is just to create a new variable for the diagonals. So promote two variables, which I'm gonna name include diagonals. Just like that, so perfect. We can now compile, save, and even close this blueprint. And now, as usual, we need a button, so I'm going to duplicate the show tile neighbor button, so Ctrl W, duplicate, and I'm gonna rename it button underscore action underscore calculate min cost, and open it. As usual, in the designer I just changed the name on the text and the action for the left click to be the new action we just created, and now we can go in the graph. Then we're gonna go here, we're gonna delete those two nodes, and we're replacing them with that. So same as usual, we're replacing the cast, so it uses the new class that we created. So now it's using calculate min cost, and we are also setting the include diagonals based on the checkbox as usual. Now we can compile, close, and go add this button in the tab. So I'm gonna go in my tabs and open tab Pathfinding. Get the button on the left, drop it in the vertical box, place it wherever you want, and add 2 of padding so it fits with the other ones. And that's it, we can now compile, save, and close this tab. And now if I press play, I go in my pathfinding, select my new action, so calculate min cost, and now if I click on my grid, okay, it selects a tile, and if I check my checkbox min cost to target, here we go. We now have the min cost generated for all the tiles on the grid. Perfect, and they are now good, so 1, 1, 1, 2, 2, 2, okay, that's good, and if I include the diagonal and generate them again, okay, 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, so it works for the square grid, but we're gonna check in 2 seconds the other grid shapes to see if it works. So here I have an hexagon grid, and we can see that it doesn't really work. All these neighbors here are costing 2, these ones are 4, but that one is 2, okay, that's weird. And what if I check the include diagonals? Okay, this time, okay, 1, 1, 1, 1, that's fine. But these ones are 2, 4, 6. Okay, that's weird. That one's 3, it's not good either. Yeah, so we have to fix the hexagon. And we have a similar problem for the triangle because let's say right now, okay, these ones are good. So 1, 1, 1, and then 2, 2, that's good. 3, that's good. Okay, that one is back to 2. Okay, that's weird. And then 3, 4, yeah. If I just go in straight diagonal, it seemed to work like 1, 2, 3, 4, 5, 6, 7, that's good. But then if I just go forward, it's like 1, 2, 3, 1, 2, 3, 4, 3. That doesn't make sense. It should be like 1, 2, 3, 4, 5, 6, 7, and here we go. So yeah, we have to fix that one, and same thing for the diagonals. When we are using diagonals, it doesn't look that great either. So we're gonna fix both of them also. And all that code is in the GetMinimumCostBetweenTwoTile function. So you can open it, and we're gonna change a bunch of things. And the first thing we're going to do is add a switch to the grid shape at the beginning of the function. That way this is the square, so this is the calcul for the square, and we're going to have different things for the hexagon and the triangle at the bottom. And this is how it looks for the hexagon. It is pretty simple because it doesn't use the diagonal, so there's only one calcul to do. And here it is. It looks pretty much the same as the previous one, so we just have a little bit difference right here. So yeah, that's it for the hexagon. You'll see it's pretty simple compared to the triangle, which is a pain, you'll see. And we're gonna start easy. We need a branch to differentiate if we are using the diagonals or not. And we're gonna start by doing the tiles that are not in diagonal. So we're gonna do the false pin first. And here's the nightmare. That's intense. I'm not gonna go through all of that with you because, I mean, it's not really useful anyway. But yeah, I'm just going to zoom in a little bit so you can see everything, and you can copy paste it if you want to. If you don't, well, as I said, the pathfinding is still going to work if you're not using that. And anyway, this is just for the triangle grid. So if you're not planning to use the triangle grid that much, well, I don't think you're gonna need that. But here it is if you want to. Hey, I'm back. I hope it was nice and fun to copy all that, and if you did, anyway. If you find any better algorithm or maths for that, just let me know, because I'm really interested to have something better than all this mess. And if you share it with me, well, I'm gonna share it with everybody else, because I mean, I think it would be nice. It would be nice to have something cleaner than all that. And that actually brings us to the triangle grid with the diagonal, so the true pin right here. And I've actually been super lazy with that one. I didn't do any of the process that I needed to do to generate this formula right here. So I didn't even try to make it work because after doing this, I was a little bit tired and I didn't do it. So instead, I just decided to just copy paste this block right here. So the same block as we are using for the square grid without diagonals, because it's pretty similar. It's not exactly perfect, but it works. So I think that's good enough for now, at least in my case, because I'm not planning to use the triangle grid with diagonals that much. So that's why I decided to not waste too much time on another big formulas that will take me probably hours just to figure out. But if you have that formula written on your side, please let me know, because I'm still interested to have it. I'm just too lazy to develop it, actually. So yeah, I'm probably going to do it if I need it in the future, but for now, it's not necessary. So I think it's not worth it to spend too much time on that, and we can just use this formula instead, which is pretty simple and straightforward. So yeah, that's it. We can just go test all that, and I think that's gonna conclude this video. So I'm just gonna play, and I'm going to do my little setup so we can see if it works. Okay, so for the square grid, I think it still works. We have 1, 1, 1, 2, 2, 2, 3, 3, 3. So if we start from the beginning, we go all the way at the end. So it goes 1, 2, 3, 4, 5, 6, and it seems to work. Okay, good. And if I include the diagonals and go in the corner, because it's gonna be easier to see, we can see that it seems to work. So 1, 2, 3, 4, 5, 6, okay, and 1, 2, 3, 4, 5, 6. That makes sense. 1, 2, 3, 4, 5, 6. Okay, yeah, good. We didn't break anything for the square. Okay, so now it's time for the hexagon. I'm gonna test. Oh, okay, it doesn't work. Oops, okay, I have a problem. I'm gonna go check what it is. Okay, found the problem. I'm actually missing 2 absolute right here because we have to do the same thing that we did right there by using the absolute for the value. So I'm just gonna do the same thing. So abs here and abs there. And here we go. That should fix the problem. Okay, good. Now we can test if it works. So I'm gonna select, okay, all the ones that are closed, it's 1, 1, 1, 1, 1, perfect. 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, that's good. And if we try to walk away from the center, it goes 1, 2, 3, 4, 5, 6, or 5, 6, 7. Okay, it seems to work. So 1, 2, 3, 4, 5, 6, 7. Yeah, that's good. Perfect. We're done with the hexagon too. And the last one, we have the triangle. So I'm going to select this one. Okay, so far so good. This is the one without the diagonal. So this is the big formula. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That works too. 1, 2, 3, 4, 5, 6, 7, 8, 9. It works. And it seems to work in all directions. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yeah, the triangle without the diagonals works perfectly. But now if we include the diagonals, it's another thing. It doesn't really work that well. That one here should be 1 instead of 3. Same for that one. This one's good though. And then 1, 2, that one should be a 2, that one should be a 2, that one is a 2, so that's good. That one 4, yeah, that's not that great. Yeah, so it doesn't work that well, but I mean, I use that one for my project and it seems to work, so that's good enough, I guess. At least it works for the main diagonals, something like that. Yeah, it's not the best, but if you find any better formula, just let me know and we're gonna implement it. And I guess that's gonna be it for today. I was planning to do a little bit more than that, but the video is already longer than expected. So we're gonna stop here for now and we're gonna continue in the next video. Donc, bye bye!